بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. This is section 4.4 exercises. So let us take some exercises about the dual of the minimization problem. Remember, we need the minimization problem here to written in the standard form like this problem. All the constraints has to be greater than or equal to positive number. So what is the question? Form the matrix associated with each given minimization problem and find its transpose. As we have seen in the section, and if you need, please listen or watch the video about section 4.4 first. We write the coefficients of y1. We start with the constraints, and then we write the coefficient of y1 in the objective function without any change. We don't do any change in the objective function in this section in writing the dual problem. Then 2, 2, and 5. Then the right-hand side, which is 16 in the first constraint, 8 in the second, and G is the right-hand side. We can write it equal to G instead of G equals. So G would be the right-hand side in the objective problem. And so this is the answer to form the matrix. This is the matrix associated with the given minimization problem. Now find its transpose. The transpose of this matrix would be 5, 2, 16, and 1, 2, 8, and 4, 5, and G. So this is the transpose of uh, the, the matrix as required. Now part B, write the dual maximization problem. Be sure to rename the variables. We said here the variables are y1, y2, while in the transpose we will call them x1, x2. And now the dual maximization problem would be maximize, not minimize, and the objective function we will call it f, and I will have it from the last row, from the objective row of the transpose matrix. So it would be 16 x1 plus 8 x2 subject to, and now I write the constraints. The first line will give me the first constraints, 5x1 plus x2. Remember, this is a maximization problem in the standard form, so it has to be less than or equal. 2x1 plus 2x2 less than or equal again to 5. So this is the dual maximization problem. That's the answer to the question. Another type of question, suppose a primal minimization problem and its dual maximization problem were solved using the Simplex method on the maximization problem. And the final Simplex matrix is given. So this is the final Simplex matrix of a maximization, dual maximization problem. Part A, find the solution of the minimization problem. Well, the minimum value of G, he said, is 452 as we agreed. So this number would be the minimum value of G. So at and now y1 and y2, y3. So how to find y1? Now how many? You have 3 rows. So this is S3, this is S2, this is S1, and this is X1, X2, X3. So how to find the value of y1? It is here, the value, the last value of s1 in the objective row. So y1 is 7 and y2 is 4 and y3 is 0. Find the solution of the maximization problem. Well, the maximum of f, now the function is f, is again 4, 5, 2. At. Now we have x1, x2, x3. What is the value of x1? This is the one. You read it from the right, 15, the number in the right hand side. And what is x2? Where is x2? Oh, x2 is non-basic variable, so its value is 0. x3 is a basic variable, and here is the one. So go to the right, read the number 29. This is the value of x3. So this is the solution of the maximization problem. Now here, use Excel to answer the following questions. So if you go to Excel and solve the following questions. Well, I need to present again, but my entire screen, so you can see Excel. Okay, so this is Excel, and let us remember how to use Excel to solve the problem. So let us put them together and try to solve using Excel. So remember, we write first the variables. What are the variables in the question? Well, the variables are X, Y, and Z. Good. And remember, we say equals 0. We put all of them equals to 0. In any problem, you can choose always 0 for the first value for all the variables. And here we write the objective function. And the objective function is this one, 8x. So it is equal to 8 times, and this is x, okay, plus 7 times, and this is y, okay, plus 12 times, and this is z. So this is the objective equation. Now let us write the constraints. So constraints, and we have how many? 3. So 1, 2, 3. And what are the constraints? The first one, you write it as an equation equals x. So this is x plus y. No, not z, y. Okay. So let me say b2. Okay. Plus b3. Something wrong. I'll do it again. Equals x plus y plus z. Okay, b2 plus b3 plus b4. That's it. And the second constraint y equals, I write y equals y plus 2 times and multiply by z. So this is the second constraint. The third constraint equals x, just x. Good. And now I write the numbers here. I have 3, 2, and 2. These are the numbers in the right hand side. And if you want to remember, when you use solver to solve, this is greater than, this is greater than. Even if you have mixed constraints, as we shall see in section 4.5, you can use Excel, and as we shall see. Now let me find the answer using solver. So solver, reset all anything before, and here you put the objective function. This is the objective function, and now you ask him, tell him that it's a minimization problem, and here you put the variables, okay, and now you add the constraints. You press add. This is the first constraint. You need to tell him that it's greater than, not less than. So it's greater than or equal to this one, add. The second constraint is this one, and again I need it to be greater than or equal to this one, add. And the last constraint is this one, greater than or equal to this one. And this is the final one, so I'll say okay. And now everything is ready. I just ask solver to solve the problem, and I let him keep the solver solutions. This is the solver solution. So the objective, the minimum problem, or the minimum value is 28 at 201. So I can write here that I can let me try to copy. I'll copy this and just put it here. Okay, I hope it will accept. Okay, here. Okay. Okay, that's good. I can move it. No, I can write on it. I don't want to write on it. I need to erase this. Yeah, but maybe here to hand tool. Yes, excellent. So I can move it. That's it. That's the end. That's the solution problem using Excel. Excellent. So maybe also I can write the answers for you to understand. We can write the answer that uh, uh, minimum of G is 28 at x equals 2, y equals 0, z equals 1. And we can check if we put x2, y0, z1, 12 plus 16. 12 plus 16 is really 28. So that's good. Everything is fine. Let us see another question. In problem, primal maximization problem is given. Okay, so now the maximization problem is given, and I need to form the dual minimization problem. Well, it is the same thing, you know. The dual of the minimization is the maximization, and the dual of the maximization is the minimization. So you can do the same steps here, but you have the maximization and you will find the dual minimization problem. Just put this in your mind. So I'll start as usual by writing the coefficients of x1 this time. And remember, this is a maximization problem in the standard form, so it has to be less than or equal to. So 3, 1, and 40 is the coefficient of x1 in the objective function. 2, 1, and 20 is the coefficient of x2 in the objective function. And here I have the right hand side. I have 120 and 50, and f now is the function written in the right hand side. Now, as usual, after I write this, I find its transpose. So 3 to 120, 1, 1, and 50, 40, 20, and I can write now f or g because I'm going to state the next problem, and I'll change the variables from x1, x2 to y1, y2, and the problem would be minimize. Okay, minimize. The function is g, and I use the last row to write the objective function 120 y1 plus 50 y2. This is the minimization problem, the dual. Okay, so they have the same solutions, such that the first constraint would be 3y1 plus y2. Remember, this is a minimization problem, so it has to be greater than or equal to 40 to be written in the standard form. And 2y1 plus y2 is greater than or equal to 20. That's it. I hope you enjoyed listening to this video. Have a nice time and study hard.